Welcome back to the atomic structure. Yesterday we have seen the Rutherford mode, and everything is looking like perfect, but there are so many drawbacks. The drawbacks are the whenever an accelerating charged particle revolving in an orbit will lose its energy and finally it will collapse. But it is not happening so. This is one problem. Second problem, even if it is considered it is a electrons are stationary and the nucleus is center, then also an attraction should be there and atom should collapse. So stabilization atom is not able to explain. Though everything is okay, it is equal to gravitational force, electrostatic force and all these things. So before going further, these things were rectified by the Niels Bohr and all. We'll see how the light is traveling, or what is the electromagnetic radiation. Then we'll come back. Say light is an electromagnetic radiation. Then what is the actually electromagnetic radiation? This is the basic physics actually. But physics and chemistry in the basics one and the same. Is not much difference. So whenever a charged particle is accelerating, then it emits electric and magnetic waves. This is called electromagnetic radiation. Once again, whenever a charged particle is accelerating, then a alternating current and magnetic fields are generated, which are propagated. These are called electromagnetic. See, there are two waves are generating. One is electrical and another is the magnetic. These two are perpendicular to each other, and one will be in z direction, another will be in y direction. Whereas the propagation will be in the third direction, that is in the x direction. So carefully listen. Propagation will be in the x direction. The other two are, the one is the electrical and another is the magnetic. It means one will be like moving like in the plane, another will be moving in the up and down, in the sine curve or cos curve, whatever that is. It is in the wave form. This is electromagnetic radiation. Very simple this thing. Whenever you are calling as electromagnetic wave equation and all, so it is in a wave. Wave means immediately one should know about what is wavelength, what is frequency, what is wave number. Wavelength is nothing but when you draw a sine curve, the distance between the two peak points or the trough points is wavelength. Similarly, the number of waves passing from a fixed point in a second is frequency. And Planck's energy equation E equal to h nu. H is a Planck's constant, that is 6.626 in 10 to the power minus 27 x or 34 joules second and all. And h nu equal to c by lambda. C is velocity of light, that is 3 into 10 to the power 10 centimeters per second or 8 meters per second. And lambda is the wavelength. 1 by wavelength, if you are calling it a wave number, then u bar, that is. So these are the small nomenclatures, and unlike the sound waves or water waves or any other waves, light doesn't require any media. It will travel in the vacuum with a speed of 3 into 10 to the power 10 centimeters per second. And this electromagnetic radiation is not only the whatever we are seeing visible, it is a very big spectrum. The spectrum starts with the gamma and ends with the radio wave. Start with the high frequency or high energy wave, gamma wave, then the X-ray, then ultraviolet, then visible, then IR, then microwave, then comes to radio wave. These are the very big spectrum. What we are seeing is a very small narrow band, that is a visible. In that also again 7 these things are there visible. So this is the entire spectrum of the any sun rays or whatever if you call it. So from this there are so many problems, is equal to h nu problems only. Sometimes lambda will be given, sometimes frequency is given, sometimes wave number will be given. So we will see the afterwards. That is regarding about the electromagnetic waves. It is a complex actually. This is a minimum required for further continuation of the Bohr model and dual nature of the particle, the small things, basics. Then comes back to again the chemistry from small point of view. Atom, how to represent an atom? Any atom you consider the symbol is X. The left side bottom will be given as atomic number and right side the top left side of the top will be given as a mass number. If you see the electron, any this thing, carbon, C, left side bottom is 6, that is atomic number, and the top left it will be a mass number 12. Here 6 means atomic number means number of protons which is equal to number of electrons if it is a neutral atom. Always you consider it as whatever we are talking for the time being, it is a neutral. So number of protons equal to number of electrons, that is atomic number. Whereas mass number equal to proton number plus neutron number. Mass number is proton number plus neutron number. So now this is the normal nomenclature. Then what is isotope, what is isobar? Isotope means same atomic number with a different mass numbers. A simple example is hydrogen 1, 1, that is called hydrogen, atomic number 1 and mass number 1. That means only one proton is available, one electron. Electron is, we are not considering any mass. And hydrogen 1, 2, that is one proton plus one neutron, and atomic number is 1. So isotope of hydrogen is, another one is called deuterium, D. Another one is hydrogen 1, 3, means one neutron, one proton and two neutrons. This is tritium. These are the isotopes. Then what is isobar? So mass number is equal, atomic numbers will be different. How it is possible? That means one of the isotope will be compared with another normal one. Example again, carbon. Carbon C614, isotope of carbon, and nitrogen 714, means mass numbers I am matching and atomic numbers are 6 and 7. So mass numbers are different, equal 14, 14, atomic numbers are 6 and 7. So this is called isobars. So isobars and isotopes will normally be used in the further these things and all. So once we are going to the dual nature and all, particle nature and dual nature, so why it is all required is this normal theories could not explain the many things like initially before electromagnetic radiation, Newton actually proposed light is traveling in a photons, means particles. Yes. Then Max Planck only has he has for the to explain the interference, diffraction of the physics subjects. So he has proposed that. That is also requires some more corrections and we'll see tomorrow. Thank you.